So if you've read problem number 2, you understand this is a binomial. Since it's a binomial, you should be able to find x and p and k from the statement of the problem. We're going to look, in this case, at 6 items, and we're going to be looking for a defective item with probability 1/4 each time we look. So x is equal to the number of successes in n trials, where we're going to replace the word success with defective, okay, number of defective items in how many tries? 6. Okay, so we're going to look 6 times. So n is 6. X can be 0. Never forget the 0. 1, 2, 3, 4, 5, or 6. The chance, each time we look, the chance of a success is 1 in 4, 1/4. You can just make this 0.25. And what's the special K? Which one of these, or which combination of these, are we interested in? In this question, we're asked what is the probability that there will be more than 5 defectives. More than 5 refers to 5 or 6. So what we need to calculate as our special K is 5 or 6. So we need to calculate probability x greater than or equal to 5, which we can write as probability x equals to 5 plus probability x equal to 6. Using the binomial formula, the number of ways out of 6 to choose 5 successes times the probability of a success to the number of successes times the probability of a failure to the number of failures. If there's 5 successes, then there should be 1 failure, because 5 and 1 make 6, which is the number of successes, and 25% chance of a success plus 75% chance of a failure, total to 1. Okay? Continuing. Now we're going to add that to 6. Choose 6, 0.25 to the 6 times 0.75 to the 0, because if there's 6 successes, then there's no failures. Okay, so we have to add up those two. The way we're going to do that is going to simplify. Anything to the power 0 is 1. 6 choose 6 is always 1. And 6 choose 5 is always 6. Okay? So all we have to multiply is stated here when you punch all of this in. Okay, I'm going to do this without the simplifications, just for practice. So this would be punching straight through 6, second function, NCR 5 times 0.25 y to the x 5 times 0.75 y to the x 1. Continue plus, and again this is on the TI 30XA, 6 second function NCR 6 times, and you'll see that will be equal to 1 times 0.25 y to the x 6 times 0.75 y to the x 0. And all of that together should give you the answer. The answer finally is 0.0046. And if you work out the options below as decimals, you can identify your answer. And working them all out, these are all wrong. The answer is 19 out of 4,096. The way you could have gotten this answer as a fraction is to maintain the fractions up here. Not important for this course. You can do everything as decimals. Okay? All right, let's do number 5. We're told about a beer drinker who's presented with 3 samples of beer, 2 of which are Molson Canadian and 1 is Labatt's Blue. What we're interested in this problem is that the person pick out the Labatt's Blue. Okay, so the Labatt's Blue is the success. The chance of seeing a success is P equals 1 in 3, because there's 3 bottles and only one of the 3 is Labatt's Blue. Okay? That's what it says here. We're going to repeat this 4 times. So 4 is the number of trials. And what are we looking for? Well, x is the number of successes, can be 0, 1, 2, 3, or 4 correct tries. What we want to answer, and it's usually in the last sentence, is the probability that he or she will correctly identify the Labatt's Blue on 3 or more occasions. So we want to calculate 3 or more occasions. So our K for our formula would have to be 3 or 4. So we have to calculate the formula twice. Once with K equals 3, another time with K equals 4, and we need to sum those probabilities. So to summarize, X and P and K, here they are. And now let's calculate for K equals 3 and K equals 4, sum them together. And when you punch all of that in, you should get D.1111 repeating. Okay, so that's what you get if you punch all this in using the approach that I showed you in past videos.